Hello and welcome to this MyGCSE Science video about organic chemistry. In this video we're going to be talking about the combustion of hydrocarbons. You may remember that in the previous video we were talking about crude oil and how crude oil is a mixture of lots of different hydrocarbons. The key thing here is to remember that hydrocarbons are made up of hydrogen and carbon only. This means that when they react with oxygen in a combustion reaction, they produce carbon dioxide and water. The best hydrocarbons for fuels are the smaller molecules. We find gases like methane in our gas taps at school. Gas barbecues and camping cookers use propane gas, and cars use octane and the slightly larger molecules in petrol. So a reaction equation would go something like this. Propane plus oxygen makes carbon dioxide and water. If I give you the formula for propane, can you write the rest of the balance symbol equation? Well, we start by writing the symbols for oxygen, carbon dioxide and water, and then we need to try and balance it. I suggest that whenever you're using hydrocarbons, you start by balancing the carbons and the hydrogens and then go to the oxygens last. So there's 3 carbons here, and there's only one thing which has carbon on this side, so we must put 3 carbon dioxides here. There's 8 hydrogens here, and those bits are going to turn into water, so to have 8 hydrogens we need 4 waters. Now how many oxygens is that? We've got 4 oxygens here and 6 here, so that's 10 in total, and that means 5 molecules of oxygen gas. This is some apparatus that's often used in labs to test for the products of complete combustion. On one side here, we'll burn some sort of fuel, in this case a candle, but you might use a fuel from a fuel burner, or perhaps even a Bunsen burner. The products of burning this candle go up into the tube and through all of the apparatus. In this U-tube we have a setup to test for water. We'll look at this test in a bit more detail in the next topic, chemical analysis, but it will either be anhydrous copper sulfate, which is a white powder that turns blue when water is present, or it will be cobalt chloride, normally in paper form, that starts off blue when it's dry, and if water is present it turns pink. So when the products are released from the candle, they're in a gas form and they flow through the pipes. As the water vapour passes into this U-tube, you can see that it's in a bath full of ice. That condenses the water vapour into water. And once the water is condensed, the copper sulfate or cobalt chloride will give a positive result for the presence of water. Any further gases will continue passing through here. You may already know what the test for carbon dioxide gas is, but if not, we'll be going through it in detail in the next topic on chemical analysis. But you may have already come across it because it's quite a common test, and it's lime water. If you bubble carbon dioxide through lime water, it goes from colourless to cloudy white or milky. Any further gases just come out the end. So you can see that this setup starts off with burning a hydrocarbon. The gas products go through the tube. In the U-tube we have a test for water setup inside an ice bath to condense the water vapour into water. And then the carbon dioxide is tested by bubbling it through lime water, and if it turns milky, that's a positive test for the presence of carbon dioxide. So this apparatus is often used to prove that carbon dioxide and water are produced in combustion. Most useful combustion is assumed to be complete combustion, but sometimes when there's not enough oxygen for the fuel to burn completely, a different type of combustion happens, and this is called incomplete combustion. In this case, we still have the hydrocarbon reacting with oxygen, but because there's not enough oxygen for it to burn completely, instead of it producing carbon dioxide, it produces carbon monoxide. Water is also produced. The problem with producing carbon monoxide is it's a toxic gas. If you breathe it in, your blood thinks it's oxygen, and the hemoglobin in the blood binds to the carbon monoxide instead of the oxygen. And this means that your body will starve itself of oxygen because the carbon monoxide takes its place. That means incomplete combustion is a really dangerous type of reaction, especially if you think about the idea that a lot of these reactions occur in people's homes or in people's cars. So it's really important to make sure as far as possible that we have complete combustion instead of incomplete combustion. Occasionally, instead of carbon monoxide, if there really isn't very much oxygen at all, just carbon will form instead. And this will be in the form of soot. Small black particles like smoke, but a bit thicker. Although soot is not poisonous, It is a type of pollution which coats buildings in cities, and if it builds up in the atmosphere can also cause something called global dimming. We'll go into this in more detail in the topic on the atmosphere. So for now, can you have a go at writing the chemical equation for the reaction between propane and oxygen that produces carbon monoxide and water? The dioxide in carbon dioxide tells us that there are 2 oxygens for every carbon. So monoxide means that there's 1 oxygen for every carbon. This means that carbon monoxide has a formula of CO. If we start trying to balance it in the same way as before, we'll have 3 carbon monoxides and 4 waters like we did before. But now we have fewer oxygens. We have 4 from the water and we have 3 from the carbon monoxide, which makes a total of 7. Although this doesn't come to a whole number, it doesn't matter that much. In general, we do like to have whole numbers in chemical equations, but it's not compulsory. If when you come to balance an equation, you end up with half a molecule of something, then that's normally okay. So in this case, 3.5 oxygens would be fine. But if you prefer to keep to whole numbers, then we just double everything. So we have 2 propanes, 7 oxygens, 6 carbon monoxides, and 8 waters. That's it for this video on combustion of hydrocarbons. I hope you found it useful. Here's a few keywords for your records, and see you again on the next video.